Welcome to Services Made Easy with WCF 4, Visual Studio 2010, and Windows Server at Fabric. My name is Daniel Roth. I'm a program manager on the WCF team. I've actually been working on WCF since it shipped first in .NET 3, and it's great to see how the technology has progressed, how adoption has grown. I think the last stat I heard was about 1 in 5 developers actually use WCF, which is just incredible. So I assume about at least a fifth of you guys have had some exposure to WCF, maybe more, given the topic. Today, I want to show you how .NET 4, Visual Studio 2010, and Windows Server at Fabric, not to be confused with Windows Azure at Fabric, although we'll talk a little bit about that too, can really make creating, hosting, and managing services really easy. I'm also going to give some sneak previews of some things that we're working on to make working with WCF services even easier. So some future content as well. You don't need to know anything about WCF to be here. I assume you're here because you want to create services, and you've heard that at least that WCF is a framework for doing precisely that. I assume a bunch of you have already started using WCF, maybe have done production applications on top of WCF. That's great. I want to help you be even more productive by leveraging these technologies. So let's create some services. So you want to create some services. What does that mean? Well, I assume that means that you want to expose some functionality. Probably want to expose it cross-process. You want it to be really easy to consume, to use. And perhaps you want that functionality to be reusable, to be shared across multiple applications. I assume you want this functionality to be loosely coupled, that you want to be able to clearly define what functionality is exposed and separate from that how it's implemented, so that at any given point, if you want to swap out a service with a different implementation, you can go ahead and do that. And in fact, maybe you actually want this functionality to be consumed not just by clients that are written on Microsoft technologies, but might be written on non-Microsoft platforms, non-Microsoft clients. No problem. Let's go ahead and do that. Let's create a WCF service. So here is Visual Studio 2010. This comes installed with .NET 4. And I'm just going to do File, New Project. File, New Project. There it goes. All right. And I'm going to create a new WCF service application. And I'm going to create here a service that is going to be an address service, like an address book. So let's call this address service. Okay. Now, a WCF service application is a WCF service that is hosted in an IS application. Okay? And this is what I get by default. Here's my service. It's just a simple class, service1 class. And it happens to implement an interface, iService1. Why does it do that? Well, that interface defines the functionality that this service exposes. And this is a nice practice. We talked about loose coupling. If you really want to start off the bat designing for that loose coupling where your contract, the functionality you want exposed and how you implement it are separate, then you can use this pattern. Now, this talk is about making things easy and simple. This pattern is not strictly required, so I'm actually going to go ahead and delete the interface. You don't need it, and I don't need it for this particular demo. So I'm going to go ahead and delete the interface from my service type as well. I'm going to get rid of one of these operations because I just need one operation for my service. Okay? So now I just have a simple class with one method. I'm going to rename my type. I'm going to use the refactor gesture as recommended by the template. This is going to be an address service. Okay, great. Now what this guy is going to do is it's going to take a person and tell you its email address. So I need a person. So I'm going to define a simple person type. Let's give it a name. Oops. And make it a little bit interesting, a complex type. Let's give it an age. Okay, so there's my person type. And then I'm going to implement a single operation. It's going to be get email. It's going to take a person. And then I want to return the email address for that person. I need some sort of address catalog. To do that, I'm just going to use a simple dictionary of string to string. And this is going to map a person's name to their email address. So nothing too fancy here. Let me populate the dictionary with something. How about myself? Daniel Roth, here's my email address. Feel free to ping me with all your WCF questions. Okay, great. So there's my dictionary. Now to finish implementing the method, I'm just going to index into that dictionary and return the email address. So person.name is the index into the dictionary. Okay? Great, so nothing really new there. This was just standard .NET development. I've created a class, I implemented it, fine. Now to make this into a service, I have to tell WCF explicitly that this is a service and this is the functionality that I want to expose. This is no different than, say, you have a class and you want to tell the CLR, this particular method I want to be public. Well, with WCF, you need to say, I want this operation to be a service operation. So first I'm going to put a little bit of metadata on this class, just a little bit. All right, service contract. This is a service contract, and I want to expose this one operation. That's it, okay? I am done. I'm going to hit F5. I have a working service. I selected the SVC file in this project. What is that thing, you may be asking? This is just a little file. I can do view markup on it as soon as. Whoa, that was cool. Okay, let's do that again. Maybe I shouldn't do view markup so quickly. F5. Okay, so a little test client's popping up. While the test client's popping up, I'm going to now go do view markup. This is just a little file. It hooks up my service type to IIS, so the IIS knows which type you want to use for your service. And notice that by using the refactor gesture, the type name got renamed for me. That was kind of nice. Okay, so that's all that thing is. Just a little file to hook up to IIS. Okay, so I got this nice test client. Why didn't that work? Service contract, operation contract. No. We don't want any data contracts. Let me rebuild. Build succeeded. In the right window. Sorry, 1 second. Let's see what we got here. Test client contains a definition, already contains an address. Oh, so I think I'm in some sort of weird bad state. 1 second, I think that runtime exception really messed something up. A little bug there. Sorry. Okay, what should have happened is that test client comes up and allows me to quickly test the service. I'll open up that service again. Okay, now this should work. Not going to fiddle with anything this time while it's coming up. Come on, baby. I seem to have hosed. I wonder if I can do it from here. Just going to do it from the command line. Add service. Let me grab the address of the service. So you see here that I do actually have a working service. This is great. So this is a service up. It's got some metadata. I do want to actually call it, though, and that's kind of, all right, let's do that. Okay. My test client not, did I break my test client? I broke my test client. Maybe I can do, no, it's complaining that, actually, that's a good, interesting point. Maybe I can build clean. I wonder if I can rename this thing. Because it's complaining that the service type it's already got one, which is obviously some sort of bug. I do have some Frankenstein bits on this thing that may have messed things up. Let me try doing this. Rename everything again, and maybe I can trick the test client into thinking that it doesn't actually have this guy already. Okay, F5. There we go. Okay, so little bug there. Sorry about that. We'll file that one. We'll get that one fixed. Okay, so here's I can see my service operations here in this nice little test client. That's great. The get email operation, that's the one I want. So I can populate a person object right here. There's my age. There's who I am. I can invoke the service. Awesome, great. So there, now I have a simple working service. No problem. Now, notice I didn't have to do much other than the bug issue to get this working. I just defined a class. It's just a class, like a little bit of metadata to tell WCF what functionality I want to expose. I didn't have to do any configuration at all to get this working. We can look at the config file quickly. There's not much in here. There is some compat switches for ASP.NET. In System Service Model, which is the WCF config, there is some behaviors configured for you, one for metadata and one for debugging. And we can talk a little bit more about those later. But all in all, not much config here. And that test client that came up, that wasn't the service itself. That was a separate process that was sending requests to the service, cross-process. I mean, now I should be able to go here and actually fire up a test client, and obviously in a separate process because I'm opening it from a command prompt. This should be my service. Let's see, 529. If I go over here and look at the development server where it's being hosted at, 529. Okay, so that's it. Great. So here I can hit that service from a completely different process, no problem. Okay, cool. What happened? Oh, yeah. Ignore that. We'll come to that one later. We'll do that one too. Okay, great. So there's my simple test client. I'm going to leave that one open because I'm going to use it later. Now, how did that all work? I mean, all I did was create a class. How am I able to now communicate cross processes? Well, to understand that, you need to understand the ABCs of WCF. If you're familiar with WCF, hopefully these will sound familiar. If not, this should help. WCF exposes functionality through endpoints. And an endpoint has three things. It has an address, a binding, and a contract. A, B, C. The address is the where, the binding is the how, and the contract is the what. The address is where you need to send the messages so that you can consume the service. This is very similar to when you want to send an email or you want to send a letter, you need to address the email or the letter so that it gets to the right spot. The binding is how those messages need to be manifested on the wire so that they can be received. For example, you may want to send those messages using SOAP, maybe using the HTTP as a transport or TCP as a transport. In addition, you may want to layer on other protocols for security, for reliable messaging, for transactions. All that information is captured in the binding. The contract is the functionality that you want to expose. For example, is this an address service? Is this an order processing service? Is this a calculator service? As long as the client and the server agree on these three things, the address, the binding, the contract, the where, the what, and the how, the client and service should be able to communicate. Now, to facilitate this agreement on what the endpoint is, services typically publish metadata about their endpoints. This metadata is generally in a standardized XML format called WSDL, or Web Service Description Language. It makes for some lovely evening reading if you're sitting over dinner and you want to open up your WSDL document and browse through it. It's awesome. But most of the time, it's processed by tools that will automatically generate client code for you and configuration so that you can then call the service. Now, there are also behaviors that can be configured for both the client and the service. The behaviors are local. They're things that are not part of that symmetric agreement between the client and the service. They're things that are about local concerns. For example, you may want to configure a behavior that specifies how instances of your service should be created in response to requests. You may want to have a new instance for every single request that comes in, or you may want to have just one instance of the service handle all of the requests. You could have a behavior on the service that specifies how you want to handle concurrent requests. Is your service implemented in such a way that you can handle them all concurrently, or do you need them serialized? Those are local implementation concerns of the service and not really something the client has to worry about. On the client side, you may configure a behavior that specifies what credentials you want to use when talking to the service. Okay, well then, where are the endpoints for my simple address service? In .NET 4, WCF will provide a default set of endpoints for you. You get an endpoint by default for each of your service contracts. Now, in my case, I only had one service contract, right? I only had that one service contract attribute. I could have implemented a service with multiple service contracts. For example, I could have had multiple interfaces that type implemented, each one being its own service contract, in which case WCF would give me an endpoint by default for each of those contracts. The address for the endpoints that you get they come from the base addresses of the service. Generally, the host of your service provides base addresses that are sort of the root addresses that your service listens on. In my case, I was just listening over HTTP. That's really all the ASP.NET development server does. But you could have a service that you've configured the host to enable HTTP and TCP or HTTP and HTTPS. WCF will automatically expose each of your contracts over each of those protocols for each of the base addresses that you have for your service. Default endpoints are a new feature in .NET 4, and they dramatically simplify the amount of configuration that you have to write, the amount of configuration that you have to manage. Now, you can still explicitly configure endpoints for your services. This is an example of how you would do that, like on .NET 3.5, and you can still do this on .NET 4. Many of you may have already done this. Here I'm explicitly saying that for this service, I want to have this endpoint with this address, binding, and contract, and I can have as many endpoints there as I want with different bindings for as many contracts as I have. But if you let WCF provide endpoints for you, you can get up and running really quickly, and it makes it a lot easier to manage your config. So instead of explicitly configuring your endpoints, you can actually get away with a service that has literally no configuration at all. Now, I told you where the address in the contract comes from for the default endpoints. Contract's just the functionality you expose, what you coded. The addresses come from your host, the base addresses that the host provided. Where do the bindings come from? The bindings are provided by you when you define a protocol mapping for your services. The protocol mapping maps from the URI schemes of your base addresses to a WCF binding. And by default, WCF will give you 4 that just out of the box will be there. For HTTP endpoints, you will get an endpoint that uses the basic HTTP binding. That's it. For HTTP endpoints, you will get an endpoint that uses the basic HTTP binding. The basic HTTP binding is basically plain text SOAP over HTTP. It's great for interop. It's very simple. For TCP endpoints, you will get the net TCP binding, which uses an optimized binary SOAP format over TCP. And it's great for cases where you're less concerned about interop and you're more concerned about just making things really fast, like for back-end systems where you know you're doing Microsoft to Microsoft. If you want to do communication that's just local to the box, you can use named pipes as your transport, and you can use the net named pipe binding. Or if you want to do asynchronous messaging, you can use queues and use the net MSMQ binding. These are the 4 protocol mappings that are provided by default. If your host provides an address with one of these URI schemes, you will automatically get endpoints for each of your contracts with these specified bindings. Okay? So, pop quiz. See who's still awake? Let's say I had a service, and the service has two contracts, iService1 and iService2. Okay? And my host has enabled two base addresses, HTTP and TCP. And I'm just using the standard protocol mappings that are out of the box. I didn't change them. How many endpoints are going to say nice? How many endpoints do you get for this service? 4, 2, 2, 4, 2. Correct answer is you get 4. So maybe let me go over this. So I have two contracts. So I should get an endpoint for each contract, right? That would make sense. I want to expose the functionality. But I also have two base addresses. That means I have two protocols that I want my service exposed over. So it's actually the product of those two. I get each of my contracts exposed over each of the protocols enabled for my service. I have a protocol mapping for each of the base address protocols, so I should get one for each one. So you get 4 endpoints, 2 contracts, each exposed over 2 protocols. Make sense? Now, that's great. That's for the default case. Things just work. But what if I actually do need to do some configuration? I want to change some settings on my endpoints. For example, maybe I want to tweak the bindings a bit. Like I want to change the security settings on the binding. Or maybe I want to change max received message size. And that's a quota that limits how much data the service will read in off the wire for a given message. Which could be important, right? Because you might buffer that whole thing into memory. You might have to process that whole thing, so you probably want to limit it to avoid denial of service issues. Well, you can do that. The simplest way to configure your endpoints in this model is to just change the defaults. You can configure the default binding configuration for any of the bindings that you're using in your protocol mapping. For example, here on the left, I am changing the default basic HTTP binding. I'm changing it, instead of to having no security, to use transport security, which means it will do HTTPS, SSL. And the way I did that is I defined a binding configuration. That's that binding child element inside the basic HTTP binding. You can define as many of those as you want, and many of you probably have done that before. And normally you would put a name on them, right? And you would then reference that name from your endpoint configurations, and that's how you would wire everything up. And you have to make sure you get the names right and the reference right, and otherwise things don't work. Instead of putting a name, just leave the name off. If you leave the name off, that means to WCF in .NET 4 that I just want to change the default. With this configuration now, every time you use the basic HTTP binding and you didn't touch anything else, you will get these default settings. Similarly, on the right side, your right side, you can change the default service behaviors. And you do that, again, by defining a behavior configuration with no name. That's that behavior tag that you see inside the service behaviors element. You can have as many of those as you want. They can have names, and you can reference them explicitly if you wanted to. But if you leave the name off, that means I want this to be the default. All my services should have these service behaviors. In this case, I've said I want to enable metadata for all of my services by default. And actually, this is what the Visual Studio template does for you. That's what the config that you saw for my simple service. Now, if you need to do configuration for one service, then you can use the location tag. The location tag is a feature of ASP.NET. It's not new, but in .NET 4 it now works for WCF as well. The location tag says that all of the config that you see inside this tag should only apply to this particular path. For example, the example you're seeing on the screen says that I want to add just this protocol mapping for just service2.svc and no other services. So that's a way to scope config for just one service without having to drop down to explicitly configuring each and every endpoint on your service. And this can be a lot of value, this model of using default endpoints. I remember I worked with a customer who had implemented a system of services that had about 1,000 contracts. And they looked at us and they said, do I really have to explicitly configure 1,000 endpoints? Fortunately, they're on .NET 4, and the answer was no, you don't have to do that. WCF can stand up those endpoints for you. It'll just work. Don't worry about it. If you need to change anything, you can, in broad strokes, change the default bindings, change the default behaviors that you're using for all those services. It was a big time saver. Now, ideally, you wouldn't have to change many settings, right? The settings should just work by default. Now, sadly, WCF doesn't have a great history here. WCF aspired to be very, very secure by default when it first shipped. And so many of it has a whole bunch of quotas and timeouts that are intended to shield your service. And they were set with very conservative values. And unfortunately, fortunately, it meant that they were very secure by default, but it also meant that they weren't very production ready or usable by default. So you ended up having to change a lot of these settings. We strongly believe that these settings should work by default for production systems without compromising any security. For example, service throttles are settings that limit the amount of resources that your service consumes as it's processing messages. Prior to .NET 4, these settings were too small. And that meant your service didn't have the resources available to it that it really needed, and it got bogged down and slowed down. In .NET 4, we've made these defaults smart. They're larger, and they're also calculated based off of your processor count. So these settings should just work. If you're not on .NET 4 yet, you should feel free to use these settings as guidance in your services. If you run into any problems with these settings as the default, you find you have to touch them at all, please let us know. We continue to try and tune these things so you just don't have to worry about these settings anymore. But so far, the response has been pretty good. These things seem to have held up. All right, let me now show you this simplified configuration model. Okay, going back to the service. First of all, I want to prove to you that, yes, you can have a WCF service with no config. I'm going to delete the config file. It's gone. No more config. Okay. I'm going to hit F5 again. This is kind of funny. ASP.NET is actually going to add the config file back because it needs a little debug turd inside of it. But ignore that for a second. There's nothing in there related to WCF. Okay, so there's my service. And yes, it is actually a working service. If prior to .NET 4, this would have blown up and said, I don't have any endpoints. I have a working service here. I can take my test client that I still have up that's still configured to point at this service. Here, let me close this guy. And I can call this service. Let's say I'm 10 years old now. And it works. So this is a fully functioning service. It doesn't have metadata. You notice that, right? Metadata is disabled. That's because we deleted all the config that added the metadata for the service. So that's not great. Let's fix that. I'm going to close this. Let me go into the web config file. See, there's nothing here. It's just this one little debug attribute. All right. So we're going to use what we learned about default behavior configurations. System service model. I want to change the default service behavior to enable metadata for all my services. So behaviors. This is a service behavior. And then I want to add a behavior configuration with no name, right? That means the default. And I'm going to say service, metadata, HTTP get. I'm going to enable metadata over HTTP, which is by far the easiest way to get it. Okay? Done. F5 again. Didn't have to specifically reference any particular service to do that. And now you can see that I have metadata enabled for my service. So that's great. Also, you may notice a sneak peek in an early feature here. I do have some hot bits on this machine. You'll see the second link here. This first link is the normal WSDL that you've always seen for WCF services. This second one is actually a flattened version of that WSDL, so it's all in one file. That makes it a lot easier to download, to copy around, and to use in interop scenarios where you need some other platform to be able to consume this WSDL. WCF WSDLs by default are factored into many files, but this makes it nice and flat and easier to deal with. So single WSDL. Look at that. Let's look at. Oh, it's beautiful. Look at those angle brackets. Makes me so happy. All right. Great. Oh, so what if I want to do the same thing for bindings? I want to change some binding setting. I know I'm hosted over HTTP and I'm using the default protocol mappings. That means I'm using the basic HTTP binding. Great. I'm going to change the default basic HTTP binding. And I don't know. Let's change max received message size. I can up it up really big. So now I can receive lots of data. And that's all there is to it. Okay. So we recommend that you follow these guidelines when you're configuring your services on .NET 4 and going forward. We recommend you let WCF add the endpoints for you to not do explicit configuration. You can still do it if you have a bunch of config already. That's fine. It will continue to work. It won't break. But you will find you'll be more agile. You'll have less config to manage if you just let WCF add the default endpoints for you. If you do need to tweak config, you can tweak the default bindings and default behaviors. If you need, you can adjust the protocol mappings to enable new protocols, remove protocols, tweak the existing protocols. And you can use the location tag if you want to configure settings for just one specific service. Or alternatively, you could use a vDir hierarchy, because those will merge together. Great. So that's creating a WCF service and configuring it. I now want to show you how easy it is to host and manage your services using Windows Server App Fabric. So what is Windows Server App Fabric? Windows Server App Fabric is an application server for deploying, managing, and scaling applications hosted in IIS 7. This is not Windows Azure App Fabric, which is a cloud-hosted technology. It's a technology that you can install yourself on your boxes. Windows Server App Fabric enables you to be able to deploy, to inspect, to monitor, to troubleshoot, and to configure your services and workflows using IIS Manager and Windows PowerShell. It also includes in-memory distributed cache, which you can use to make efficient use of memory in a reliable way. Now, how do you get it? You can get it using the link that I've got up here. There are two ways to install it. There's the web platform installer, and there's a standalone installer. The web platform installer is great for like a dev machine where you just want to lay down everything that you need to get up and running with Windows Server App Fabric, the persistent store, the monitoring store, and so forth. Everything you need to just get up and running. For server machines, you can use the standalone installer, which gives you a little bit more flexibility. How does Windows Server App Fabric fit into the overall picture of creating and dealing with services? Well, the foundational hosting layer is still the same. You're still using IIS, you're still using WAS, the Windows Activation Service for non-HTTP protocols to actually host your applications. You implement your services the same way. There's nothing different there. You use .NET, use technologies that you know, Windows Workflow Foundation, Windows Communication Foundation, ASP.NET. Windows Server App Fabric layers on top of IIS and provides a set of runtime services and components. You get a persistence store for your workflows. I'm not going to actually talk a lot about Windows Workflow Foundation in this talk, but there's a lot of other talks around workflow services and hands-on labs around dealing with workflow services and Windows Server App Fabric. You should take a look into those if you're interested in the workflow side of things. But workflow is a great technology to use for implementing services that are long-running and durable. So you get a persistent store. You also get hosting and monitoring infrastructure, and you get the distributed memory cache. You can interact with and extend, actually, Windows Server App Fabric using a set of management APIs that are exposed through PowerShell commandlets. You implement your services and workflows in Visual Studio, and then you manage them using WF and WCF-specific IIS manager extensions. For single box deployments, Windows Server App Fabric will integrates with Server Manager. And for multi-machine deployments that are managed using System Center, you can use the Windows Server App Fabric management pack. You get a lot of benefits out of using Windows Server App Fabric as your host. You can deploy your applications using technologies that you probably know and love, like web deploy. You can easily monitor the health of your applications and troubleshoot issues using out-of-the-box monitoring infrastructure. And we'll show that. You get rich configuration UI for configuring and dealing with runtime configuration settings like security, performance, metadata. And you get support for auto start. Auto start is a feature where you can configure a service to automatically warm up instead of having to wait for the first message to arrive, which is the default mode in IIS. All right, let's take a look at Windows Server App Fabric. So on my development machine, on my development machine, I've already installed Windows Server App Fabric. I used the Web Platform Installer because it gave me everything I needed. It already installed the persistence store for workflows, the monitoring store for tracing data, and it did that on top of SQL Server Express. It also installed the management extensions into IS Manager, so I can use those. Then what I want to do is, for my development, I would like to use Windows Server App Fabric for development as my host. That's actually a really simple thing to do. There's not much to it. Remember I said that Windows Server App Fabric layers on top of IIS. So all you need to do if you want to use Windows Server App Fabric as your development host is switch from using the Visual Studio development server to using local IIS web server. And then you can create your vDir. Okay, great. So now, as a developer, I can take advantage of the monitoring infrastructure for debugging issues, and I can take advantage of the configuration tooling for configuring settings. That's a nice setup. I highly recommend it if you're doing development, if it's available to you. It does require admin privileges in order to be able to host on IIS. No, it does not. It does not work with IIS Express. Okay, great. I've already actually done all the development on my service, so I don't have much to do here. What I really want to do now is deploy this service to my production environment. Now, normally this would mean creating a package, handing it off to someone who manages that environment, who would then deploy it for me, because I'm not allowed to touch that environment. For simplicity's sake, I'm going to use my dev machine is going to double as my production environment, but I'm still going to go through the steps. So what I do is, this is all done using web deploy. I right-click on my service, and I say, build a deployment package. And that's going to build a package that includes everything that I need to install my services on IIS. Okay? I can configure how that package is built by going to the properties page for my project and going to the Package Publish Web tab. Here's a bunch of settings that I can fiddle with. For example, I can see where the package is being created. I can see what the default site is, where the package will be deployed, and the default application name where the package will be deployed. I'm going to leave those defaults, but I'm going to grab the path where the package is being built, because that will be useful for me to deploy later. Okay, great. I already built the package. It was built successfully. So now I'm going to go to IIS. And the way you deploy that package is you pick the site where you want to deploy, right-click, deploy, import application. Okay? I'm going to copy in the path that I got from my project settings. There's my package. It's just this zip file. Okay, next. This wizard shows me everything that's in that package, and I can unselect things if I don't want them deployed. That looks fine. I get an opportunity to change the application name if I don't like what was done at the development time. I picked it myself, so I like it, so I'm going to keep it. Poof, done. Okay, so here you can now see this one is my development environment for that service, and here is the deployed production version of that application. Pretty easy. Yes, I believe the technology is web deploy is part of that family of technology. So like web deploy is maybe something you're already familiar with like doing ASP.NET applications. It's the same technology. You can use that same technology to deploy to App Fabric. Okay, great. So I was able to deploy the application. But how do I know that my services actually got deployed correctly? How do I know that my endpoints are actually exposed? If you get an exception like this one, this is an endpoint not found exception on your client, it can be really frustrating. I mean, what do you mean my endpoint's not there? If it's not where I expect it to be, then where is it? I mean, is it exposed at all? How many endpoints is my application exposing? How many endpoints are exposed on my box? These are questions that can be kind of tricky to answer with something like WCF, which is a little bit more ethereal in nature than, say, something like a GUI app where you can hit F5 and you can see it. There's my app. I can see the UI. With services, where are they? How can you see them? Windows Server App Fabric can give you transparency into your services and endpoints that are deployed in your applications and on your machine. Let me show you that. Okay, now you'll notice here in IIS Manager that Windows Server App Fabric added these 3 new icons to the management experience. I can double-click on services, and I can now see all the services that were deployed as part of that application. And there's my one service that looks right. I can select the service, and I can see some additional details about the service down below, including some of its configuration information, like what service behavior name it's using, is auto start enabled for it or not, what level of monitoring is being done for it, etc. I have options to filter and group the services in my application in interesting ways. I could have a lot of services here that I need to look at. And I can look at not only services in my app, but I can move up the hierarchy and see how many services are in this site. There's all the services that are in that particular site. I could do the same thing at the server level. Going back to the app, if I double-click now on endpoints, this is showing me all of the endpoints that are exposed for my application. By default, this is only going to show me the application endpoints, the ones that are related to the functionality that I implemented on my service type. You may also want to see system endpoints, like where are you exposing metadata. You can see those too. You just need to remove this filter. There's my metadata endpoint that's exposing my WSDL, and there's my application endpoint that's exposing my address service endpoint. Here I can see the address, the binding, and the contract of each of my endpoints. The address is empty here because these are just being exposed directly on the base address of the service. The binding can be seen here, and the contract. This star means that this endpoint was actually added by default by WCF. It wasn't explicitly configured. I can select an endpoint, and I can see more details about the endpoint below, including information about its configuration, like its security mode. This doesn't have any security enabled for it. It's just using the default basic HTTP binding. I can filter and group the endpoints in different ways, and again, I can see, for example, how many endpoints are on my box. Where have I opened listeners, which can be pretty useful. Cool. All right, cool. So now I know that my services and endpoints were successfully deployed, and that the endpoints are exposed. How can I tell that they're functioning properly? And when things go wrong, how can I troubleshoot what the issue is and then fix it? Well, Windows Server App Fabric can help you with this because it gives you a centralized monitoring store. Without Windows Server App Fabric, if you want to do health monitoring, and even troubleshooting, it was fairly labor-intensive. With health monitoring, you may try to use performance counters or ASP.NET health monitoring. You may have to write some custom code to do that. With troubleshooting, you could use the actually a fairly rich set of traces that WCF emits through system diagnostics. Those are good, but they have some drawbacks. To actually turn that on, I have to go into config and add a whole bunch of config. I generally have to restart the app to get that config picked up, which means I got to rerun the repro. System diagnostics actually has a fairly heavy perf hit if you run it in production. It's not something you usually want to just leave running in production. And then it generates traces usually into separate files, and I have to go collect all the tracing data and then analyze it. And that's quite a bit of work. Windows Server App Fabric leverages new functionality in .NET 4 for WCF, where we enabled event tracing for Windows for WCF, or ETW, which is a highly efficient, production-ready tracing infrastructure. It collects all the traces from WCF and stores them in a centralized store and provides management tooling so you can query and then view this tracing information. Well, let me show you that. Okay, let me go back to my app. Here's my app. Now notice that there is a App Fabric dashboard icon here. I can select this. And this gives me a nice high-level view of what's going on with my services and also my workflows. We're going to focus on the services here. Here I can see the WCF call history, which includes how many calls have completed, how many errors have occurred, and even how many service throttles have been hit. Now, I don't have any calls here because I haven't called the service since I deployed it. Let me go ahead and do that. Now, this service is actually the one that was at design time. It was before I deployed, so I'm going to need to remove this one. Let me add a new one. So the new service is at localhost, address, service, deploy, and service 1.svc is the one I care about. Thinking. There it goes. Okay, so there's my service. That looks good. I'm going to call it. Let's see. Let's call it a bunch of times. I'm going to hit this button like 4 or 5 times. There it is. Okay. Now going back here, what's happening is there is Windows Server App Fabric has an event collection service that collects all the events about roughly every 20 seconds, I think, is the interval, and puts them in a store. And then this UI queries that store and shows you what's been done. So I should see a bunch of completed calls. There they are. This will show me the completed calls that I made using the test client and also the ones that were done to actually fetch the metadata. So I had 13 completed calls. Down below, I can see which operations received the most hits. This gives me an idea of where the load is in my service. I can see details about errors. If I click on these metrics, I can see the specific tracked events that were used to calculate those metrics. Here, now you may wonder, wait a minute, there was 13 before Dan, and there was only 4 here. What happened there? Well, Windows Server App Fabric actually will aggregate the tracked events so that they're easy to see and that they can be more easily stored. Each of these tracked events is actually an aggregate operation completed event. And if I look down below, I can see the aggregate count. Like this one was only 1. That one had 6. So those are actually that one tracked event actually represents 6 calls. I can see the operation that completed for each of these tracked events. These are the get requests for the metadata. Here's the get email requests that I did using the test client. Okay? Cool. So those were some completed events. Let me cause some badness to happen. I don't know. Daniel R. What's Daniel R's email address? What happened? These type of errors. We said we wanted loose coupling. Unfortunately, one of the drawbacks of loose coupling means that if something goes bad on the service, you don't really know what happened over there, right? Usually, if you had a bug in your service or something was misconfigured, that meant you had to go to the server side, you had to enable tracing, or you had to attach the debugger, rerun the thing again, see if you can figure out what happened. Fortunately, I'm hosted in Windows Server App Fabric, which is already collecting that data for me. And so I can just go ahead into the dashboard and see exactly what happened. So I'm going to go back to the dashboard. There's an error. Okay, let's look at that. What was that? Okay, here's the tracked event for the error. I can see some details down here below. There's a key not found exception that got thrown. I can look at the stack for the error. Looks like it's being actually thrown from my code, from get email. Oh yeah, I didn't do a very good job implementing my service. I'm just indexing into a dictionary and the key might not be there, which causes an exception to be thrown. I can now go and fix my problem. You can see how this can make you really much more productive, like a development time. If you're using this, you can just always have this tracked information available, and so you can fix problems quicker as part of the development process. Okay. Yeah. Well, if you're on .NET 3.5 SP1, what functionality do you get, if any? You do get some level of support. The tracked events that you're seeing are all ETW based, and 3.5 SP1 isn't instrumented directly for ETW, so a lot of that functionality won't light up. Later, I'm going to show you some configuration. Actually, in just a minute, I'm going to show you some configuration UI. Some of that is just as applicable to 3.5 SP1 as it is for 4.0, so that stuff will work. So you get sort of a limited experience on top of Windows Server App Fabric, but you can still use it. Okay. In addition to actually being able to see these troubleshooting problems, you can also do configuration to deal with your runtime configuration. You can deal with your metadata settings, your monitoring and diagnostic settings. You can tune for performance. You can configure for security. You can configure auto start. And Windows Server App Fabric provides you some tooling for doing that. So quickly, I'm going to show you how you do that. Going back to IS Manager. To look at the configuration for your services, you just right-click on the node where you want to configure. It's hierarchical in nature. Like you can configure at the root node, all the way up at the server, and those settings will apply to everything down below. If you configure for a site, it'll apply to everything in that site, and so forth. So you can define up above and then override down below. I'm going to go ahead and do at the application level. You go to Manage WCF and WF Services, Configure. And here I get a nice configuration UI, and I get some tabs. For general settings, I can enable or disable metadata. I could maybe do this, for example, at the server level and just say, every server should have metadata. let's just do that, and then maybe I disable it for specific services that are a little bit more sensitive. For monitoring, you can see here are the settings for actually configuring the monitoring store. Writing events to the database is enabled, and this is my connection string to the database in SQL Server Express. The default monitoring level is health monitoring. This will give you errors, warnings, and pretty much the bare minimum needed to drive the dashboard. You can up it to end-to-end monitoring, gives you more information, troubleshooting for if you really need to dig into a tricky problem. You can also just turn it off, like you don't want to have the burden of collecting the information, or you don't want to pay even that little performance penalty for ETW tracing. There's also an option here to enable the legacy system not legacy, but the system diagnostics tracing, if you want to do that as well. Again, it's not really something that you would want to do in a production environment because it does have that perf hit. It will cause the app to restart, but you can do it here. I'm going to skip over workflow persistence and host management since those are workflow specific, but there's some good stuff around workflow configuration. You can disable auto start for your services so that they're nice and warm. This is useful for like if you want to make your service discoverable and you want to host it in IIS, you kind of have to do this because you want a discoverable service to be able to respond to find requests. And for it to be able to respond to a find request, well, it's got to be up and running. You can't have it be message activated. So this is a good way to make your services discoverable. You can change your throttling settings here. Now, like I said before, we did some work where we tune these things where we think they're production ready now. So hopefully you don't have to touch these things at all. If you do, shoot me an email, let me know why, because you shouldn't. But you can if you really, really want to. You can also change your security settings. You can configure a certificate for your server that will be used in message security. You get a nice certificate picker UI instead of having to try and type a thumbprint by hand. Great.
I just have a question. When you change the configuration, does it going to reflect in the config file?
Yes. So the monitoring store is centralized. You can share the same monitoring store across multiple nodes, and you can view all that data when you're managing any of those nodes. The configuration data is actually config file based still. There is no configuration store in Windows Server App Fabric. It's unfortunate. It's still file based. So when you're looking at that UI, you're just dealing with that one node. In Windows Azure App Fabric, they do have a configuration store, and they do have a centralized config management story. So a lot of good work being done there, a lot of exciting features for WCF. Looking forward to seeing more of that. I highly encourage you, if you haven't gone to a Windows Azure App Fabric talk and heard about the application manager and those features, you should go hear about it. It's pretty cool. All right, great. So I hope you've seen how easy it is to just create and host and manage services. You should use Windows Server App Fabric. You should use VS 2010. You should use .NET 4. But there's more coming. This is just the beginning of a path. We want to continue to make configuring and managing your WCF services easier. We're taking a threefold approach here. First is you should have to configure less. And we started doing that with the default endpoints. We tuned some of the defaults. We think we need to do a broader scrub of the defaults. I'll show you where we're at with that in a couple of slides. You can take a look at the settings. Again, ping me if you see any that you're like, wait, my production environment, that wouldn't have worked. We'd like to know about those. We want to integrate better with the host. You shouldn't have to configure security in WCF and security in IIS, right? Like if you configured security in IIS, you should be done. We want to integrate better with those type of host configuration settings. And we want to have a great client configuration story. We need to clean up the generated client config. And finally, with Windows Azure App Fabric, great feature there is you get runtime service discovery integrated with the platform. That's Azure App Fabric, not Server App Fabric, but it's coming. And so in that world, you actually just don't worry about your client config. It's handled and resolved by the system and resolved at runtime. It should be easier to configure things that you do need to configure. We're doing some good tooling work around config IntelliSense, validation, tooltips, so that when you're editing that config file, for all you who have lots of endpoint configurations in your config files, you can get a better experience around managing that data. In some cases, you may actually just want to write that config in code. Enough with the XML. Like, just let me write this config in code. You could do that in .NET 4. It was a little tricky if you were hosted in IIS. You had to hook into some extensibility points. We wanted to make it really easy to do code-based config. I'll show you that in a second. And then I already mentioned centralized config in Windows Azure App Fabric. It's great. You get a nice centralized UI for dealing with all of your settings for the entire app, not just for a single node. When you misconfigure things, they should be easy to debug. I mentioned ETW tracing in .NET 4. It's a little light on the content. It's not quite as rich as what you get with system diagnostics. We want to beef that out so it really can replace any scenario that you need system diagnostics to diagnose. You can just use ETW, which is production ready. Yeah?
Any opportunity to provide some centralized config file management tool outside of App Fabric?
Centralized config management tool outside of App Fabric. We don't have any plans to do like file management type stuff. We currently strongly believe in the centralized store and tooling around that store. So the plan right now is that App Fabric is the thing. That's the direction. It's going cloud first. I think you'll hear that the plan is also that it comes on premise. That is the long-term thinking right now. All right. But if you had like App Fabric adoption blockers, that's a concern. We would love to hear about that, and we may talk about that afterwards. Okay, let me show you some of these great new features. Okay, I have a WCF service here. Oh, there's so much stuff. Let me see. My resolution makes it hard to see. Okay, I have a simple WCF service here. This is just the default template. I didn't touch it actually. Let me close. It's just got a get data method. It's the standard thing you get when you do new project, okay? And then I also added a console application where I want to actually consume this WCF service. All right, so what I'm going to do first is I'm just going to add a service reference to that service. For those of you who haven't seen this before, it's really easy. You just discover the service and the solution. Okay. This is where it's going to get the metadata, it's reading the WSDL, generating some code. There's an error. Why is there an error? All right, let me rebuild just to make sure. Ready. What does ready mean? Rebuild all successful. Okay, so I should be clean. And let me just make sure this guy is up and running. Could not be found. Okay. That means I've got some sort of config issue. Let's see. Here's my right there. Okay. Build again. Yeah, here I'm hosting an IS Express in this particular case. So I don't have to have admin privileges. All right, now I'm doing that again. Add service reference, now it should work. So there my type, I hadn't messed with the type and I hadn't updated the SVC file. I didn't use the refactor gesture. Oh, shame on me. Okay, great. I got a service reference. And I can use this service reference now to consume the service using console service reference. There's the namespace where the code got generated. That's the client type that got generated from the WSDL. I'm just writing some code into my console application to consume the service. Get data 2, something like that. Okay, that's how you would do that. If I go look at the config file that got generated, it's pretty basic. I see a single, it's actually what I would expect, right? I see a single endpoint. The client needs to know about the endpoint. I see a single endpoint. It's got the address binding and contract. It's HTTP, basic HTTP binding. If I look at the binding configuration that it's referencing, there's nothing tweaked on it, just the default basic HTTP binding. And it's nice and clean. There's nothing else that really shows up here. That's great. Now, I mentioned that I want to integrate better with host settings. So here's what I'm going to do. I'm going to go into my WCF service. And this is hosted in IS Express, and there's some UI integration that's been done here, so I can fiddle with some of the IS Express settings. Right now, you can look here, it says anonymous authentication has been enabled, SSL is not enabled, and neither is Windows authentication. I'm going to enable those. True, I want SSL. I want Windows authentication. And I'm going to actually turn off anonymous. Now, if I did this in like IIS in like .NET 4 or prior, it would blow up. WCF would blow up and say, I'm trying to expose a basic HTTP binding that needs anonymous, but the host doesn't allow it. And so that's not okay, so I'm going to blow up. Instead, what we think should happen is that the WCF should inherit the settings from the host. I'm not configuring WCF here. I'm just changing what the host does. I'm going like the IS manager and fiddling with the authentication modes that are enabled. Okay? So that's all I did. Now let's regenerate that service reference. So I've got SSL and Windows Auth enabled. So that means I have two base addresses, right? I have HTTP and HTTPS, and Windows Auth should be enabled for both of them. So it should be two endpoints. I have one contract, two base addresses, two endpoints. All right, let's look at the config that we get. So I got two endpoints. One of them is HTTP. One of them is HTTPS. That means my service is actually exposing HTTPS endpoint without me having to do anything. So there's now a default HTTPS protocol mapping. So that's pretty sweet. And if I go look at the bindings that are used by those endpoints, one of them is transport credential only with Windows. So that's that's just HTTP with Windows. And the other one is transport security with Windows. That's HTTPS with Windows. Exactly right. Yes, question?
Is this current or is this future?
Future. We're going to have futures here. This is future investigations, things that we're looking at, interested in feedback on. Yes, this is futures. But we think this really helps simplify aligning with your host settings. Also, I'm not really showing here, but it was also supported, is that endpoints in these bits can have more than one auth mode enabled. In WCF 4 and prior, you can only enable one authentication mode per endpoint. In these bits, we allow you to, as many boxes as you check in IIS, an endpoint will be exposed that supports all of them. Now notice this config is still, again, it's pretty clean. It's just exactly what I said. Like there's nothing else here. If I had done this on .NET 4 or prior, this is what I would get for the config file. I would get this crazy, it's like someone threw up on the config file. And this is because all the default settings are showing up. We finally cleaned this up. All right. Also, if I want to do some configuration in, let's say I want to do it in code. Like I don't want to go messing around with config files at all. I like my config file nice and clean. We are thinking through a model where you could do that. And the way you do it is you can just add a simple method to your service type. I'm going to add public static void. If you've seen WCF data services, it's kind of similar model. A configure method. And it takes a new type called a service configuration. And instead of writing all my endpoint configurations in config, I can just write them here. Instead of defining protocol mappings in config, I could just write them here in code where I get IntelliSense and the C# compiler to help me out. I can do things here like I can opt into loading the actual config file. By default, it won't get loaded. If you go code, we say, okay, you're just going code all the way unless you tell us otherwise. You can opt in and say, no, go also load the config file because I got a bunch of stuff there and then I want to add to it. That's fine. You can do that. You can add service endpoints just like you would on a service host, except here you don't actually have to hook in a service host factory and get a hold to the service host so that you can do that. Of course, that's not, that's explicitly configuring endpoints. You can also, there's a new model here, you can say, I want you to just enable a protocol. This is like defining a protocol mapping. Like I could say, I want to use the WS HTTP binding for HTTP. And that would just say for all of my contracts on my service, expose them over the WS HTTP binding. Very simple code way of doing configuration. Now, I mentioned that many of you may have lots of config already with explicit endpoints. We've got something for you too. Let me show you that. In the explicit model, you have to actually go in here and configure your service and every endpoint on it. So the way you do that is you go into the services section. Now, I don't know if you noticed, but I'm getting tooltips over these config sections to help me know what all these things are. WCF has a lot of settings, and sometimes you don't have no idea what the heck they are. You can just now hover the mouse over it and get some idea of what some of these settings are. Let's configure a service. And here I have to specify which service I want to configure. Notice I'm getting IntelliSense here. Prior to in .NET 4 and prior, you would have had to know what the string is, the right string is that goes in this name, which is the full name of your service type. And people get this wrong all the time. And then their config doesn't get picked up, and they wonder what the heck's happening. Here we're giving you IntelliSense where you can just pick the right one. There it is. That's my service. Awesome. I can configure my endpoints, address. Let's do a text one. Binding. Here I'm going to do basic HTTP binding. Contract. Again, for the contract is a type. I'm getting IntelliSense over the contract. Let's find my contract. There's iService1. That's mine. Okay, let's do another endpoint. Let's do a trickier one. Address, let's say binary. Here I'm going to do the previous one was text SOAP over HTTP. It was basic HTTP binding, nothing special. Let's do a custom binding here where I want to do binary SOAP, but over HTTP. We don't have a out-of-the-box binding that does that for you, but you can create one. So that's what I'm going to do. I'm going to do it for the same contract. Okay. Now, to do a custom binding, I actually have to go create a custom binding configuration. I have to say what that custom binding is. So I go into my binding section, custom binding, and create a binding configuration. Here I do have to provide a name. You can't just define what the default custom binding is. That would be weird. So I'm going to give it a name. This will be binary HTTP. Okay, so let's use binary. So binary message encoding and then just HTTP. Okay, great. Now if I go back to my endpoint, I'm going to do binding configuration. Notice I'm getting IntelliSense even over named things in the config file, like named binding configurations, named behavior configurations. You now get IntelliSense and validation over that part of the config file. Validation meaning, like, if I go into my service type here that I did nicely using IntelliSense, so it's all correct, but if I happen to mess it up by hitting the delete key because I decided I don't like that one, down here you can see I'm actually getting a squiggly in the config file and a warning here saying, hey, that service type doesn't exist. Similarly, if I go into code, this is why it didn't work the first time, because I had done this and didn't fix it. And I don't use the refactor gesture, and I change my service type, and I build. Oops. Build. Again, I'm going to get a validation error telling me something that's wrong. And I can fix that and rebuild, and those validations go away. Okay? So that's some new stuff. Are you going to go away? Go away. What's wrong with this? With binding configuration? Oh, that's not. Oh, there it goes. It went away. Awesome. Okay. Just took a little delay there. So that's some futures coming down the road. I also mentioned that we are scrubbing our config defaults. This is a big table. There's lots of settings on here. But the message here is that we've gone through all of our, all the really archaic WCF transport settings and timeouts and really thought hard about what is the right default for these things so that people don't have to worry about them most of the time. And then we took those settings, we made them the defaults, and now we're running our stress and our perf tests on them to make sure that they're production ready. And we also did all the security analysis to make sure that these things are not violating any security guarantees that we made previously. And hopefully this means that you don't have to worry about a lot of these settings. I would love if for your existing services, if you just took these settings and tried them out, compare them to what you got. If any of these settings don't match up with what you currently have, let us know. But hopefully this means that you have to configure a lot less going forward.
Would you recommend those for a 4-app or 6-app?
Yes, for both. They're universally applied. That they constitute our current guidance. Thank you for coming. I hope you've seen how easy it is to create services, to host them, to manage them. We're continuing to invest in this space. We want to make services easier to configure. We want to make them easier to configure security for, to monitor and troubleshoot. We've done a lot of work in this space, and we continue to do it. Please leverage Visual Studio 2010. Please leverage .NET 4. Please leverage Windows Server App Fabric. And I would be happy to stick around and answer any questions that you might have. Thank you very much. Yes? Yes, it is supported on Win 7. Win2K, Win2K-R2, Win2K8. I think it goes back. It's about as far back as it goes. It's the full supported list.
Can you use the WCF monitoring if you're inside a Windows service? You don't use IIS?
Yes. So if you're on .NET 4, the E2W tracing is independent of your host. Regardless of which host you're using, you can get those traces. Now, the nice tooling and let me come down. Trace collection that you get on top of